Right. So good morning to one and all. It gives me great pride to welcome our resource person for the day, Professor M. Pant. Sir is a PhD in computational physics with a professional degree in law. He has taught at MNIT, Allahabad, the University of Western Ontario, Canada, IIT Kanpur, and Indira Gandhi National Open University. He has been deeply associated with the IIT system, having his PhD from IIT Roorkee, being a faculty for about a decade at IIT Kanpur, and a member of the Board of Management IIT Delhi for 6 years. The topic for today's session is quantum readiness. Sir, please, share your insights on the same with our students.
So thank you, Polita, for organizing this, and a special thanks to Mustafa for providing the tech support to make this happen properly. It's a great pleasure for me to be talking about the quantum world to young people, especially at school, college, wherever they are. You see, the various ways of starting on this, but I want to kind of begin with drawing your attention to some of the news items which have been there in the internet.
Sir, you're not audible.
I think, sir, you're not audible, please.
Let me ring him up and say.
You have dialed is currently busy. Please try later. आपके द्वारा डायल किया गया नंबर अभी व्यस्त है. कृपया कुछ समय पश्चात प्रयास करें.
Hello, can you hear me now?
Yes, sir.
Yes, sir. Yes, sir.
Okay, fine. So I think there was something that default mute, but I unmuted. But anyway, so we can start, right?
Yes.
Okay. So I said, let me begin by thanking Polita for organizing this and Mustafa for providing the tech support so that we are able to see all these slides. The topic of today is an introduction to the quantum world, a question of an awareness. And the reason I am very excited about it is that, as Polita has said, it is like for me something which is really something which we were waiting for. So this actually is something where we are saying that there are two interesting aspects coming up. One is that computers are moving towards what is called quantum computing, and they're using quantum computing to solve problems of quantum mechanics. So as I will take you through my narrative, so my foray into computers itself actually came via quantum mechanics. So for my PhD thesis, I was doing solid state physics, where we were talking about quantum mechanical problems and solving them with the traditional computers. Around 1980, Richard Feynman said that if you want to do quantum mechanical problems, then you must have a quantum computer. And the race for quantum computers, or in fact the emphasis for quantum computers, really came around 1980s. Until recently, it was considered purely theoretical concept. And always people would say, if there is a quantum computer, we can do this. When there is a quantum computer, we can do this. And this was the state of the art. And therefore, few people were doing this kind of a semi-theoretical stuff. In the last few years, this has changed completely. And this is why I want to share this with you, that it is very important for young learners to start exploring and learning quantum. In fact, quantum technologies. So I will tell you the big news first, straight away. You might have seen on the internet, it might have trickled down to you that in October 2019, Google achieved quantum supremacy. Now, quantum supremacy is a word which was a phrase which was created by John Driscoll, who was a professor of physics at Caltech, the same place where Richard Feynman was. And he said there will be a time when a quantum computer will be able to solve a problem which no classical computer can do. And the news on 23rd October 2019 was that Google's quantum chip called Sycamore could do in 200 seconds something which the fastest supercomputer called Summit would not be able to do in 10,000 years. And companies like IBM challenged this a little bit and said, no, using another method, they could do it a little earlier and so on. Now, the reason I'm saying this is that last week's news item is China has also achieved quantum supremacy. And what is very interesting is that on the 8th of October 2020, right during this deeply contested election for Donald Trump, the US took a policy decision about how they will prepare the young for a quantum world. And this is what I want to draw your attention to. That now is the time to be ready for a quantum world. And Purita talked about my association with the IITs, and I therefore want to share something with respect to that. The IITs were trailblazers in education in India, especially engineering education. Now, engineering education existed in India for quite some time. There is Guindy College of Engineering, which is the oldest engineering college in India, probably the oldest outside Europe. We had Banaras Engineering College. We had many others, Roorkee University, or Roorkee Engineering College, and so on and so forth. But IITs transformed engineering education. In fact, they were no longer called engineering colleges, but institutes of technology. But apart from many things which are part of the IIT system which make it very good, I want to draw attention to two things which are very interesting. Prior to IITs, engineers used a device called a slide rule. A slide rule was an analog device where there are several scales and you use the scales to do simple multiplication using logarithm thing, log A plus log B is equal to log AB and so on and so forth. The IITs were the first generation of engineers who used computers to solve problems. The IIT Kanpur had an American computer. The IIT Delhi had a British computer, ICL computer. IIT Chennai had a German computer. IIT Powai had a Russian computer. But the common thing was that they moved from traditional slide rule driven computing to programmable computing of those times. The other thing which was very interesting about the IIT system was, and I've been part of engineering education before I joined IIT as well. In other engineering education, the sciences were considered to be irrelevant. They were called service departments. They were all merged into one. I was in Engineering College, Allahabad, physics, chemistry, maths, humanity, everything was merged into one, and it was called a service department. In the IITs, physics, chemistry, maths were separate departments with an entity of their own. And may I now tell you something, that they were teaching quantum physics also to all engineering students. Now, 60 years later, we're seeing that quantum computing and quantum technologies are coming into their, you say, rightful thing. And what I am trying to tell school-going learners, that it is time for you to also start looking at these things, because this is what the future is. There are a large number of opportunities in the quantum field, whether you're talking of US, or you're talking of England, or you're talking of Canada, or you're talking of Germany, or you're talking of China, and so on. In fact, even India was not to be left behind. In the last budget, February 2020, the finance minister had made an allocation of some 8,000 crores for quantum technologies. Of course, because of the COVID, etc., that thing did not really happen, but this is what was actually part of the design. And there are some initiatives. So Indian Institute of Science in Bangalore has an initiative on quantum technologies. Roorkee University has for its engineering students one course, one semester course on quantum technologies, which is in collaboration with Microsoft. So the point is that this is something which is the futuristic. So just like the IITs flourished, IITians flourished because they were ready for the age of computers and computer programming and the science-driven problem solving. This challenge today is that if people are well versed with some of these things, they will be ready for the future. And you can go through so many huge. The other big news is that you can learn much of this on your own. So earlier what would happen, as I said, IIT Kanpur had an IBM computer, IIT Delhi had an ICL computer and so on. But today you don't have to have a computer, or you don't have to have a quantum computer to learn quantum computing. They are all available in the cloud. All the companies, whether it is Microsoft or Google or IBM or D-Wave, they're offering these things as cloud-based services and a lot of support for the self-learner. So this is basically the broad story. I'll develop this as we go along. So one of the things I'm saying is 2020, we should not look at just Happy New Year, we should look at Happy New Decade. And this is the third decade of the 21st century, which is a transformational decade and is a decade which is basically for people like you. If you're 15 to 18 to 20 now, the next 10 years are going to be wonderful transformational years. And if you will take the lead, like the IITians took the lead at the time, you will of course flourish and thrive as well. So can we have the next slide? So yeah, so why learn quantum? And one is for the same reason that everyone should learn something about art and music and philosophy and all the rest, because it shows the very best of what humanity is capable of. And what I want to really share with you is that we think, or we thought, that quantum is only the business of physicists and high-end physicists, somebody who will go into looking at fundamental particles, etc., etc. But because quantum is the basic theory of nature, is the basic description of nature, it applies to physics, chemistry, biology, and you may not find it believable, but even it will be important for finance, understanding these kind of things. So in some sense, I want to say this, and this is why it is for everybody. Just like we say that school level maths is for everybody, no matter what you're going to do, you learn your basic geometry, etc., and so on. Quantum is going to be the same thing in the coming decades. There's a very famous quotation. Next slide. There's a next slide. Yeah, so this is about geometry. So I just mentioned in passing that very thing. So when geometry was kind of, the state of the art, like I'm talking about quantum today, there was a time in 430 BC or something, where geometry was the basic thing. And Plato's Academy said, let no man ignorant of geometry enter here. So they said it's Plato's Academy, and this thing. It's the same way. For the future, it will be no one ignorant of quantum will be part of the mainstream people. There will always be a certain number of people who will continue to be, but what we call knowledgeable people, not. The next slide. So the next slide is from Euclid. So Euclid is the one who created geometry in some sense from those 5 axioms and all the corollaries, etc. But when that Egyptian king, Ptolemy, he came to Euclid and said that, but this is very difficult. Can't you have a simpler method of geometry? And he said, no, there is no royal road to geometry. Similarly, there is no royal road to quantum mechanics. You have to learn it, go through it. And of course, once you start learning, just like many of you, once you started learning geometry, you must have started enjoying it and kind of, rushing to come to and say, and come to QED, and that is this thing. So in a sense, what I'm trying to say is that this is just progress of human knowledge. There was a time when geometry itself was a very important fundamental barrier to people to learn. It was very useful because all measurement, etc., and space-related things, and a large part of geometry got developed because of what is called the curse of the Nile. So when the Nile River got flooded and when the waters receded, you want to be able to give the same amount of land which people had, etc. And therefore you had to work with area of land and area of different shapes of land and so on and so forth. So, next slide. Can we, next slide, please? So I'm just giving you, I will be telling you mainly in a story type narration, but I'm giving you a certain structure. So we'll talk about the backdrop, the development of quantum mechanics, India's contribution to quantum physics and quantum computing. And you will be surprised that we have already made contributions to quantum computing. Quantum mechanics on a classical computer, Feynman's exhortation to build a quantum computer, and then quantum supremacy that I just now talked about.